Hey guys, this is Brian, and I want to show you 3 derivative tricks not often taught in class. The first trick is how to easily take the derivative of a square root. These will come up a lot, so this is one that I use probably almost every day when I'm working. Now the old way of doing this is you would have written the square root as x to the 1/2 power, and then used the power rule for derivatives. But what we're going to do is just memorize our own trick. And the trick is the derivative of a square root is 1 over 2 times the square root. And you're done. It's simple as that. And that's the same thing that you would get if you took the derivative here, right? The derivative of x to the 1/2 is 1/2 x to the minus 1/2, which is the same thing as I have written here. So say it with me one more time. The derivative of a square root is 1 over 2 times the square root. If it's not just the square root of x, let's say I had something like this, okay, well, it's the same rule, just apply the chain rule. So the derivative of a square root is 1 over 2 times the square root. And then since there's something on the inside, I'll times by the derivative of the inside by the chain rule. That's how to easily take derivatives of square root functions. The second trick I want to share with you is when you have to take derivatives of a number over x to a power, or the reciprocal of x to a power. And the way we do this, it's actually using the reciprocal rule, which is sometimes taught and sometimes not. But here's how the trick goes. We change the sign, so this one's positive, I'll make it negative. I multiply by the exponent in the bottom. So in this case, the exponent of x is just 1. So I have to do 1 times 1 is 1. And then I add 1 to the exponent in the denominator. And you're done. So the old way you would have done this is you would have written 1 over x as x to the minus 1, and then used the power rule, and you'd get minus 1 times x to the minus 2, which is the same thing as I have written above. So sometimes if you have to do a lot of these, this gets time consuming. So that's why I just remember the rule, flip the sign, multiply by the power in the denominator, and then add 1 to the power in the denominator. Let me show you another one. Let's say I wanted to take the derivative of this thing. Well, I'll use my new shortcut rule, which is I switch the sign, so this negative will become a positive. I multiply by the power in the bottom. 6 times 7 is 42. And then I add 1 to the power in the bottom, and that's the derivative of that function. My last trick is if you have a derivative that just looks awful, like look at this thing. This would be a terrible derivative to do normally. I've got like a quotient rule, and I'd have 2 chain rules inside, and it's really awful. So what I'm going to do is I'm going to do something that's usually taught, which is called logarithmic differentiation, but I'm using it in a way that you're just not used to using it. You're used to using logarithmic differentiation when you have a variable to a variable power. But if I use it here, if I just take the natural log of both sides of this equation, what I'm going to do is apply properties of exponents on the right side. And I'm going to do this all in one sweep. I'll show you how easy it is. So remember that if I have the log of something divided, I can write it as log of the top minus log of the bottom. And remember that if I have the log of something to a power, I can write that as the coefficient. I can write that power out front. That's not to be confused with the power rule for derivatives. This is a property of logarithms. Now the reason I did this is because if I take the derivative of both sides, the derivative is very easy to do now. Because I'll just apply the rules for the natural logarithm derivative, which is whatever's on the inside goes on the bottom and the derivative goes on the top. Whatever's on the inside goes on the bottom and its derivative goes on top. And I also have to take the derivative of the left-hand side, and it's a log, so whatever's on the inside goes on the bottom and its derivative goes on the top. Now y prime is the answer, so I'll multiply both sides of this equation by y. And actually, I know what y is, don't I? Y was that original thing that we had up there. So I'll just replace y, I'll write it over here to the right. And there you go, there's your derivative. So did you see how fast that was, just using logarithmic differentiation on this, as opposed to doing it the old ways, like doing a quotient rule with chain rules inside? And you know, it's really not too bad. You just take the log of both sides, apply some properties, take the derivative, and you're done. Okay guys, so those are my 3 quick tips for making your derivatives hopefully a lot easier and quicker. If you liked this video, please subscribe for more tips and tricks to make your math life a lot easier, and have a great day.